Hey, welcome back to MathCat. This week we're going to be talking about area. Let's start with a definition. Area is how much flat space a shape covers. And we measure it by counting squares all the same size, called unit squares. In fact, these squares are one row by one column. So they're all the same size, they're all 1 by 1. And then when we find the answer, we say the answer in square units. So for example, 20 square units. So how you find it? You make or imagine a grid of equal squares, of these unit squares. So in this picture here, we have 4 rows by 5 columns. And these rows and columns are made up of unit squares. So we could count them to find the area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 unit squares. But we know from our video on arrays that the equation for this is 4 by 5, 4 multiplied by 5 equals 20. So we don't need to count the individual squares, although essentially that's what we're finding when we calculate the area. We're finding the total number of squares that covers our shape. So area tells us how much space is inside a shape. Remember, each little box is 1 unit square, and instead of counting every box, we can group them and calculate rows times columns, and that gives us the area. So the area equals rows by columns. Let's go ahead and start with an example. MathCat wants a rug that is 8 rows by 4 columns. If the rug is covered by unit squares, how many square tiles will the rug have? So our picture here has 8 rows and 4 columns. So let's write our equation is 8 times 4, and that equals 32. If we had a grid of unit squares and laid it on our rug, we would have 32 of those unit squares. Let's look at another example. MathCat is helping paint 2 walls in the classroom. The first wall has an area that is 6 feet by 4 feet. The second wall has an area that is the same as the first wall. What's the total area MathCat will paint? So this one is a little different than the first, where this time we have 2 areas. So let's draw a picture of our wall. We have 6 feet by 4 feet. And we have another wall that's the same size, 6 feet by 4 feet. The second wall we know is the same size as the first wall. So what's the total area? Well, the area of the first wall is 6 times 4, and that's 24. And we're going to add another 6 times 4, which is 24. So if we add 24 plus 24, we get a total area of 48. That's the total area that MathCat will paint. So another tool that you might come across in order to find the area is sometimes the total number on one side of your shape or both sides of your shape is a large number, and you need to break it up because you don't off the top of your head know what the multiplication equals. So here, let's say you've only learned up to your 5s in multiplication facts, but here you have a shape that's 8, 5 plus 3, 8 rows and 3 columns, and you're just like, maybe you haven't learned 8 times 3 yet, so you can't compute the total, but you know 8 is 5 plus 3. So you can calculate the area of 5 times 3 and then add it to the area of 3 times 3. So this is kind of using the example in the previous problem where you had two areas and then you add the areas to get the total. So here you would have 5 times 3. I'm going to put that in parentheses so we know that's one area, plus 3 times 3. So that is the orange area plus the white area. So this is orange and this is white. And we're adding those together to get the total. So that's 15 plus 9. And that equals 24. Now, if you did know your 8 multiplication facts, you could write this as 8 times 3, which we know is also 24. So you get the same answer either way. It's just sometimes if the number is really big, you can't do the multiplication off the top of your head. You can decompose the total area into 2 smaller areas and then add them. So when you look at the operation we've done here, we've actually done 5 plus 3 multiplied by 3. And the reason is we've done the rows, which is 5 plus 3, and we multiply that by the columns, which is 3. So this is what we call the distributive property. And the distributive property distributes the value being multiplied, which in this case is 3, and that gets distributed to the 5, so that becomes 5 times 3. Usually we write that in parentheses just to keep it separated. And then we plus, and now the 3 gets distributed to the second value being added, so we have 3 times 3. Well, look, that's exactly what we wrote before when we did the rows by the columns. We did 5 rows by 3 columns plus 3 rows by 3 columns. And that's exactly what we have. And so we get the same answer here, 15 plus 9 equals 24. So you might come across problems that talk about the distributive property, and what that means is you're going to distribute the factor being multiplied to each of the factors being added. So the distributive property looks like A plus B times C, and that equals AC plus BC. A similar concept is a word problem that describes two areas of different sizes, but they may not have one size in common. So before we had the 3 columns was the same, but here you might have areas where the rows and the columns are different, but you still do the same thing. You still find the area of each shape and then add them together. So let's look at this one. MathCat is helping plant flowers in the yard. One garden is a rectangle that's 5 feet long by 3 feet wide. The other garden is 6 feet long and 4 feet wide. What's the total area of both gardens? So let's draw a picture. So you have one that's 5 feet by 3 feet. So you're always going to start with your picture so you can see what's going on and what you're trying to solve for. And the other one is 6 feet long and 4 feet wide. What's the total area of both gardens? So just like the example we had with painting the walls, we're going to find the area of each shape. So this one's row by column. 5 times 3 equals 15. And this one is 6 times 4 equals 24. So the total area is 15 plus 24, and that is equal to 39. So that's the total area of both of the gardens. A slightly different type you might see with problems like this is where one is a rectangle and one's a square. But it's still the same approach. You're still going to find the area of each shape and add them together. So let's look at this example. MathCat is designing 2 play areas in the park. Play area A is a rectangle that's 8 meters long and 2 meters wide. Play area B is a square, with each side being 3 meters long. What's the total area of both play areas? So again, let's start with our picture. This one's long and skinny. It's 8 by 2 meters. And play area, so this is A. Play area B is a square that's 3 meters long. But what do we know about a square? A square is the same on all sides. So this is play area B. So the rectangle area is 8 times 2, and that's 16. And the square area is 3 times 3, and that's 9. So the total area is 16 plus 9. You add those two together, and you get 25. So that's the total area of both play areas. I want to talk about some common mistakes, some common misconceptions to watch for. So the first is perimeter versus area. And the perimeter is the length of all the sides. So in this problem, the perimeter would be 4 plus 5 plus 4 plus 5. So the perimeter is the distance you would travel if you walked around the shape. And the area is the rows by the columns, so that's 4 times 5. So don't get those mixed up. Remember that the perimeter is the total length of all sides, so think about walking around the shape, how far you would walk. And the area is the number of unit squares inside that shape, so remember the grid of rows by columns. The other mistake that comes up is adding the rows and the columns instead of multiplying. So remember, so that would be saying the area is 4 plus 5. So remember that you multiply for area. It's 4 times 5. So those are just some common mistakes that come up, so things to keep in mind on your homework and tests. Thanks for watching this MathCat video all about area. Now you know how to find the area of rectangles by multiplying the length and the width. And when you have two areas, you can add them together to find the total area. Area helps us measure how much space something covers, like a garden, a rug, or a playground. Thanks for learning with me today, and I'll see you next week.